Planes navigate through the use of a combination of instruments and systems. Here are some of the most important elements. 1. GPS. Planes use GPS, Global Positioning System, to determine their location, speed, and altitude. GPS uses a network of satellites to provide precise location data. 2. Inertial Navigation Systems, INS. INS uses accelerometers and gyroscopes to measure the plane's acceleration and rotation, which helps determine the plane's location and direction of movement. 3. Air Traffic Control, ATC. ATC provides guidance to pilots on their flight path, including takeoff and landing instructions and any changes in their flight path due to weather or other conditions. 4. Navigational Aids. Planes use navigational aids such as beacons, radio signals, and radar to help guide them along their flight path. 5. Flight Management Systems, FMS. FMS provides pilots with real-time information about their flight path and helps them plan the most efficient route to their destination. 6. Instrument Landing System, ILS. ILS is a precision approach system that provides guidance to planes during landing, even in low visibility conditions. History of flight navigation. The history of flight navigation can be traced back to the early days of aviation, when pilots relied on basic instruments such as compasses and maps to navigate their aircraft. As technology advanced, new navigation aids were developed to help pilots navigate more accurately and efficiently. In the 1920s and 1930s, radio navigation systems such as the Radio Direction Finder and the Automatic Direction Finder, ADF, were developed, which allowed pilots to navigate by using radio signals from ground-based stations. In the 1940s and 1950s, the development of radar and the introduction of the VOR, VHF omnidirectional range navigation system greatly improved navigation accuracy. The VOR system uses ground-based stations to transmit radio signals in all directions, allowing pilots to determine their exact position relative to the station. In the 1960s and 1970s, Inertial Navigation Systems, INS, and Global Positioning System, GPS, were developed. INS uses gyroscopes and accelerometers to measure an aircraft's motion and calculate its position, while GPS uses satellite signals to determine an aircraft's precise location. Today, navigation technology has advanced even further with the introduction of satellite-based navigation systems such as the European Galileo and Chinese Beidou systems. These systems provide even greater accuracy and reliability, allowing pilots to navigate with unprecedented precision. Aviation and maritime guidance. Pilotage refers to the act of guiding or navigating a ship, airplane, or other vehicle through a specific course. It involves the use of various instruments and techniques to ensure the safe and efficient operation of the vehicle. In the context of aviation, pilotage typically involves the use of visual references, such as landmarks or geographical features, to navigate the aircraft. Pilots may also use electronic navigation systems, such as GPS, to aid in their navigation. In maritime contexts, pilotage may involve the use of charts and other navigational aids to guide a ship through a particular area. A pilot, who is an experienced mariner with knowledge of the local waters, may be employed to assist with the navigation of the ship. Pilotage is an important skill for pilots and mariners alike, as it ensures the safe and efficient navigation of vehicles through various environments. Navigation without electronic aids. Dead reckoning is a method of navigation used in the absence of GPS or other electronic aids. It involves using mathematical calculations based on the last known position, direction, and speed to estimate the current position of a moving object. The term dead reckoning comes from the nautical term deduced reckoning, which was used by sailors to estimate their position at sea. The technique was later adapted for use in aviation and other forms of transportation. To use dead reckoning, you need to know your starting position, your speed, and your direction of travel. You then use this information to estimate your position at a later time. This can be done using a variety of techniques, such as measuring the time and distance traveled, or using the compass to determine your direction. One of the challenges of dead reckoning is that errors can accumulate over time. Small errors in your initial measurements can lead to larger errors in your estimated position. To minimize errors, it is important to use accurate measurements and to regularly update your calculations based on new information. Dead reckoning is still used today in certain situations, such as in military operations or when navigating in remote areas where GPS signals may be unreliable or unavailable. However, it is generally considered to be less accurate than GPS and other modern navigation technologies. Non-direction beacon, NBD. A non-directional beacon, NDB, is a type of radio navigation aid used in aviation. It is a ground-based radio transmitter that emits a low-frequency signal that can be received by aircraft equipped with ADF, automatic direction finder, receivers. NDBs are used to provide pilots with a bearing direction to the beacon, but not their exact location. This information can be used to navigate to or from the beacon, or to determine the aircraft's position relative to the beacon. NDBs have a range of up to 200 miles, 320 kilometers, during the day and up to 400 miles, 640 kilometers, at night. They are used in areas where other navigation aids such as VOR, VHF Omnidirectional Range, or GPS, Global Positioning System, are not available or unreliable. However, NDBs have some limitations, including susceptibility to interference from natural and man-made sources, low accuracy, and the fact that they only provide a bearing to the beacon and not distance. Because of these limitations, NDBs are becoming less common and are being replaced by other, more advanced navigation aids.